Alright, let's continue to the topic 3, which is machinings. So, as you know, before we go to machinings, we have to prepare a stock material that is reflecting to the stock material that we have. There's a few ways to do a stock material. Okay, let's say right now we have a model that is 300 by 300 by 100. So we have a material that is 400 by 105. What we can do is just use the design function here to create something related to it. And the good thing with design is we can always add it back. So let's say we have 400 by 105 material. You can always play around with it. Okay, so this is just an example. Now this is 400 by just let you know that the measure tool will not work on some model. Okay. Okay, right now we just jump to the machining. Okay, first of all, to understand the machinings, here you have to understand that the first layer here is your main layer. It's like your master layer. There is also your machining group. Okay, you can. This is also your machine kinematic. But let's say you have a 3-axis machine, you will need to change it to just the 3-axis milling machines here. If you are on the other module, you can always change, like you have 4-axis, or even you want to use a robot, you can just change the module here, but we will just focus it on the 3-axis. Okay, it's just for me to save the model. Okay, we have a 3-axis machine milling here. Then first step you want to do is okay, we have to turn on the geometry so that we can see the model we have. And first of all, we just go to workpiece, which is the material. Then we will extrude this one and click extrude, and just give it the thickness of our material. Let's say this one is negative 40. Just add. Then we got our material. Okay, then we can adjust our workpiece. Yes. Okay, let's say because since we are planning quite well, so this is definitely right on the spot that we want. Let's say it's on the middle. We want to start machining to ensure it's on the middle. This is the right spot. But let's say you want to change your machining G54, which is your machine origin. You can just click, just go to the setup and select the workpiece CS, and pick this one. Then you can just you can just basically place around, or if you enable the smart snap, you can make it snap to the corner of your workpiece, or the corner of the line if you have. This one to go to the top. Oh. If you can't snap, you can also just key in the value if you know. So 0 is here, and we know that the material is 400, so this one should be 100. Oops, 100. Divided 2, 55.2, 52.5, then this one should be 100 or negative 10 if you are placing it on the corner. But if you have let's say you have a sketch or the line here, you can also make it snap if you want. But this is not good at snapping. Okay, if you want to make it snap, you can just this one, you can just join, and then now we have a join curve. Much more easier to snap. Yeah. Okay, if you have a problem with snapping, you can just join curve it so that it have a contour, so to help it more easier to recognize it. And with a smart snap, it will automatically snap to the point. Okay, so let's move back. Let's say I just want on the center, so just move back in the center. Okay, so this is how we set up our setting before machine. Okay, so first of all, let's say we want to have a first process. We want to have a face milling. Just go here, new, and just go to the 3D entry, face milling. Okay, first step of all, you just have to go to the tool and change the give the tool information. Let's say this is tool number 1, and you have 3 mm face mill. Face mill is also a cylindrical mill. Just import the working length, shoulder. This is all the tool information. I will suggest that you just try to make it as close as possible based on the tool you have, and also the tool number related to the tool. Okay, and you can try to add a holder if you want, or you can just create your own holder if you also want it. This one you can just add on, and you can just you can just create your own holder if you like. But anyway, since this is my 3-axis machining, so this is not really necessary. As long as you just give it the correct working length, it should be fine. If you don't know what it means, you can just always forward it, then the hint will be coming up, so you can know what does it refer to. Okay, so after we have finished the tool, we can edit the spindle speed and also the feed rate. Okay, here is a calculator. If you know the cutting speed, let's say this is aluminium, it's around 100. As you can see, it will give you the spindle speed. Okay, this is an example. Let's say you have already know what to use. You can just simply just keep it in the RPM you want, and also the feed rate that you prefer. And all other feed rate here is different feed rate for different what we say this cutting operation. As you can see here, this is a finish feed, plunge feed, and it's controlled by percentage. 100% means all this will be based on your working feed. and this is 100% means that it's same like working feet. Let's say your plunge feet you want it in different feed rate, you can either change it. If you don't want control it by percentage, you can just click here and change it to the setting you want. For example, 200. Okay, so percentage, you just give it the percentage. Okay, you can just click here and change to ml per minute, so you can always play around with it. After this, since this one is face milling, we want to face on all the material, then we don't use any job assignment. Okay, we can change the machining type. Okay, you can adjust the step over. Okay, top final level, let's say I want to face like 2 mm, so my final level will be -2, and there's no pin or high here. So the number of parts and the depth step means that the depth step is with one cut how many you are going to cut. So these two is related. Let's say I just change it to 0.5, it will automatically become 4. So if this one is 5, this one will be 0.4. So it is actually related, so you can just choose one to edit. Let's say I want to cut 1 mm, so it will automatically divide it by 2. Okay, so just after finish this, we can just click run. Okay, so you will see the path. Then if we want to change it more, we can just go to links and link here, to try to change the safe level 20. Distance is also 25. Okay, lead in and lead out, we can change this one. So lead in and lead out means the entry here. If we want it more, we can just add on 20% of 2, because it is already extended. So it's 50%. After you edit, you just click run. Okay, so you have more pass over here. This is 100%. Okay, as you can see, this one will be longer because you will extend 100%. So this one, let's say I just extend 20% of the this should be fine. Okay. After this, you can just go to simulation. Okay. Just click the last one, machining without visibility. Oh, this is the last one, so you can just reset. So it will change and based on the material given here. This one. And then just press play. Second pass. Now you have the face milling done. Here you can just, in the simulation here, you can just extend it so that you can have a better study on each of the work path it goes into. Okay, so back to machining. Now we want to, let's say we want to cut out this contour, or let's say we just want to cutting this one now. So our next process, we can do cutting. Okay, then we're just selecting our tool. We are using tool number 2. Let's say I'm using MU, which is 25 mm width. The working length is 25. Then I just want to add on a holder. Okay. Then you can just skip the overhang, which is the tool length. You can just paste it on your machines. If you have a tool presenter, then you will know the overhang of a tool, which is your tool length. Okay, also same thing, you just give it your RPM, working feet. You can just change this around, but you can just always change this around if you want. Then you can just select this one, this one, this one, this one. And pocket. So I just want to cut like 5 mm. It's 2.5 mm. Strategy. The step will be 2 feed rate, then job assignment, strategy. There's a lot of strategy you can choose. Okay, each strategy use different cut pattern. So just choose. You can just try around. This one is the step over. Let's say I just want a straight away cut, 100% cut, so I can use a smaller step over, 2 mm step over, or using percentage, 10% step over, so 2.5. Okay, no relief. Okay, no routing extra stop. Okay, then we can just try running. Notice that you can't change your pocketing direction. Okay, so this is automatic generated by Sprut, so you can change it. You can only the start pocketing direction we can't do it. This is just to let you know. But we can change our main type, then some of the time it will change the cutting positions. Then you can just reset. Okay, if you want to skip the first process, you can just click this one, simulate up to the current operations, then run. Okay, so look at this one. Then next, I want to do pocketing on this one. So I can just copy this one, paste this one. But let's say I'm using a different tool. So this one's tool number 3. Okay, we use the 8 menu. Okay, then we just change this one. Maybe use a higher RPM and feed rate. Okay, this just change the pocketing region. Add pocket. So this one will be -2 because we're already machining -2.5. Go to the level that we want. So let's say we have to reach like -40. Oh, sorry, it's not -40. 5. 20. Just based on the drawing given, you just go to the bottom level that you want. Then you can just change the depth step to mm. Let's say I want to cut like 1 mm per cut. And the depth step is like 40. You can just change. If you want to have a better finishing, you can just add the radius stop. So you can have a 0.2 mm leftover material for your finishing process. You can just run. Okay, so you get your first pocket done. Now let's say you want to copy this one. You can just go here to the transformation, multiply 2 by axis, multiple step, so it's 50 and 6. Okay, based on the drawing given. Okay, so this information you should have if you have a drawing. Can you just run again so that you can automatic copy of this. Okay, very nice. Let's say the copy pocketing number 3, but our target now is this one, this one. Okay, so this one have a problem because this is not joined. So what we're going to do is we'll have to try to join this thing. Luckily, in job assignment, there's a line function which can help us to draw the line. So this one is 2D, so we might have some problem that we will be facing. So let's go back here. Try to join them. Let's cut this one out. Here you have to draw. Okay, you can also draw one. Just try to draw this one here. This one here. Okay, so just back here. Now we have drawing. This one, this one, this one, this one, this one, and this one. This one, control, this one, and now we can join. Also took out this drawing line. Here let's try to join this 4 line. Okay, now we have a contour. So a 2D geometry usually is a little bit troublesome if we don't have a good geometry. Let's say, then it will be a problem. So we always need to have a geometry to help us complete geometry. Okay, so back to here, you can just go to add pocket. Now just you can just click add pocket, or if no selection, you can just click this one, and you can just go here and search for the drawing that you want. So it's on the part, join to, join to. So this one is like A20, A25. So we can just run it. Okay. Remember we have the stock, radial stock 2 mm. Now we want to get rid of it, so we can add on the finishing process, which is called the contouring. Okay, so you can just use the same tool. This one, just select this one. Maybe you want to have a smaller fit rate because this one is for finishing. Cool. So this one should be on the inside. Okay, we have to offset in. Okay, select this one and change the arrow to change the offset direction. And you can select another curve. Just click curve. Then we can also here join curve. We want this one, so add. Same thing. We want a compensation inside. Okay, so oops, we can do both in the same process. So I will just copy and paste these two. So I have two contouring. The one is for the outer and one is for the inner. Because both of them is in different height level, so I cannot do them on the same strategy. So this one will be -2 to -20, and depth of cut. Yeah, this is a finishing, so I can basically just do it one shot. Okay, so finishing without any stop. Okay, we can add on the English, and when we run, we can see the English line here. So 90 degrees, so that we can have a better entry. Okay, let's try simulation. Okay, so we'll give you a finishing process. Just copy this one. So we copy 6 times. Now, if let's say because this element is just a contouring, so you will left this one uncutting. So let's say you can also use the pocketing strategy for finishing. It's the same. You can use this one. After the pocketing number 3, you can just paste. Of course, you can rename it as well. And you can just throw away the but rather stop 0, so it can also work like a finishing. Just change the color so that it become more obvious, and then we can just change the gap step, so because it's finishing, we can just change this one to 100. Okay, so it can also work like a finishing. You can also upon recommendation if you want, so you can just skip this one and reset, then we just skip the previous simulation, so it's also finishing. There's a two way to do it. Okay, so there are two way of doing it. Either you want to use a pocketing, or you can use a contouring to do your finishing. Okay, so either one will work. Yeah, if you don't want, you can just unenable it. So let's just focus on this one. Maybe I just delete this one and copy this one. Same. So this one, copy and paste. Contouring 2. We just need to change the curve to this one. And set offset and change the arrow direction. Finishing of this part. Oh, of course, we have to change the angle to 20 and 25. Okay, use that, skip. Okay, so this one is just to add on the finishing on the wall, but let's say you don't want another finishing, you can just change the radius stop here to 0, so there will not necessarily be any residue. Anyway, this is just an example. Now we have open back this one. Now let's say I have a hole here, I want to do some drill hole, so hole machining. Okay, let's say the first process will be a center drill, 6 mm center drill, 120-degree angle. Oh, this center drill is too long. We just like 80, working length like 10. Okay. So this one is tool number 5. Okay, just go for the RPM. 200. Then you can just select all the circle hole. Click center, then this should include the machining. Just select all, go to properties, and define the machining height. So just like 2 mm. The H is your drill depth, so if you want to do like 2 mm, so do 2 mm. Okay, so this is simple drilling. NC code format, you can use longhand, you can just use a G code, or you can use a 10 cycle. So you can choose either one. Okay, so if you worry the 10 cycle doesn't work, so you can just always use a G code. Okay, since this is cam, you can basically generate the code related to the drilling process. And you just run, and voila, you have 4 centrifuge ready to go. Now you realize that we have forgot about this also. This is also a pocketing slot. We have to do something related to this as well. Okay, let me just select all these things. Just click Control while you're selecting them. Just join. So this jointers ready. This here as well. Then you can just off this one so that you can have a better visual on this one. So off the workpiece. Okay. Now I want another drawing. This one. This one. So just cut all this line, go to the join tree here, and paste it. Then select everything here, and join. Okay, this is much better. Right, now go back to machining. Should have done that one before this one, so we will continue using the pocket here just to copy and paste pocketing number 4. Delete this one, and we want to have pocket. Just straight away select the joint here, add. Okay, so we'll straight away select all the pockets, and so it's -2 to -7. Okay, this one we don't need the finishing, so 0. Oops, okay, because we have this one, so no need copying. Reset, skip, play. Okay, then go about this one, drilling. Okay, so this one you have to change as well. Okay, just go to the job assignments, select everything, properties. This one change to -7, and I want my drill get to be H there. So this one, the jack minimum will automatically change. So just click OK. Done. Okay, continue our drilling process. Copy and paste. Now it's a pack drilling. And change our tool to normal drill. This also 6 mm drill. This one have a working length of 155. Okay. Speed. Same hole but different depth. Properties. Now I want to do like 15 mm. Sorry, that's too fast. 15 mm, so it will drill to -22. And you can select you want the drill tip or not. Okay, so without drill tip, usually you won't get a full 22 mm drill because of the tip, which have a taper shape. let's say you activate it by using the drill tip compensation, you will automatically offset with the drill tip taper. It will take into account, and it will give you a full length of -22. Okay, just press OK. You just change the strategy here now to chip breaking or chip removing. Either one will have a similar effects. Okay, let's say you want a bottom drill around 3 seconds, maybe 3 installation 1, 1. Okay, this is the pack drilling process. If there's too fast, you can just run again. Okay, as you see, this is the pack drilling process. Okay, and you can just go into transparency to see the effect. Okay, let's say this hole, you want it to make it bigger, so maybe like 6.5 or maybe 7 mm. You can always also use a hole machining. Okay, just copy and paste. Hole machine number 3. Okay, same hole, but this one we want to change the diameter. So here, open this. Now we want to change them to the 7s, and the drill drag will be -7 to negative. We just want like 10, maybe like 5. So just go to -5. Okay. No. I want to do a pocketing based on that, so I will change to cylindrical mill. Okay, using also a 6 mm tool. Now this one we can change this one. Okay, 5. So this one should be off, and we can do hole pocketing. Then you can play around with the spiral step, everything here. Then run. As you can see, it will go spiral. So yes. So we'll do a pocketing hole. Finish pass one. Okay, you can always play around so that you can do a better finish if you want. Okay, then maybe you want to add on a countersink. You can copy and paste by using a bigger tool. Just give it the correct information. Properties 7. This one's maybe 8. I will just try it. Okay, so we'll give you a countersink. Maybe there's too much, you can just change. I don't know, this one, maybe just 1 mm. These, just off it. Again, skip process. Okay, this one so this is a 1 mm composite. Okay, so that's basically what you do. You just need to, after finish it, you want to post, you can just go to post process. Okay, select the correct post processor. Okay, after this one is milling. Okay, there's a lot here. Okay, for milling, okay, so let's say it's high and high. After you select, as you can see, you can just you can also select the process that you want, or you can just skip the process that you don't want. Okay, then here NC founding, you just go and open the log, select the place that you want to save, and on the desktop, give it a name. Yes, cut. Okay, then you just click run. So it will generate the G code. If you want to edit it, you can use the external editor, and you can just edit the process. Then you can find the post process here. Alright, okay, so that's all for the 2D machining example.